Welcome to recording 1C in our series on completing the square for Chapter 3 of Mathematics 2200. We'll be focusing our attention in this one on analyzing and using quadratic functions in problem-solving situations when the function is already given to you. Here's our example. You've got a frog sitting on a rock and it jumps into a pond. The height of the frog above the surface of the water as a function of time t in seconds since it jumped can be modeled by this function h of t equals negative 490t squared plus 150t plus 25. We're told to graph the function. I've already done that right here using technology, in particular my TI-84 graphing calculator. I'll go through how I did that in a moment. But first, let's understand where I got the scales from. We need to know what a reasonable scale might be here for each axis. Now, the y-intercept of this graph is 25, so that's a bit of a guide there. We're probably going to need something more than 25 because the graph opens down and the 25 is probably not the maximum. So by a bit of guessing and checking, I can come up with something around 40 or 50 would be reasonable to go vertically. And I've gone by 5s because I don't want to go by 1s to get up to 40 or 50. Now, the time scale. Here's what I did. I calculated the value of the vertex using negative b over 2a, since this one is in standard form and not in vertex form. Also, thinking about the problem context, this frog is jumping, so it's literally only going to be in the air for probably a fraction of a second. So decimal 5 is probably adequate. If it's not, you can always adjust in your problem situation. Now, what is the y-intercept? Well, we can tell the y-intercept very quickly from the graph. It's 25. We should also be able to tell it's 0 and the c value because we're in standard form. So it's 0, 25, and it represents the height of the frog when it first jumps, or just as it's jumping. So it's the height of the frog at time 0. Height of the frog, that's above water, of course. Above the water at t equals 0 seconds. We need to do some other analysis. Just one moment while I paste that graph over to this slide. Here we go. What maximum height does the frog reach, and when does it reach that height? Well, we've already calculated the t value of the vertex. All right, the maximum height occurs at the vertex. So we have already calculated that the t coordinate is something like decimal 1531 approximately. We need to figure out what the q value is for the vertex, which will give us the maximum height. All right, so I've gone into my graphing calculator and I have to type in, by pressing y equals, I have to type in my function. So negative 490 x, I have to use x instead of t because that's the button available there for my calculator. There's the x button. Square that x plus 150x plus 25. I make sure my window settings are set up like I've demonstrated there on the slide. 0 to decimal 5 for my x values, going by decimal 1s because that's reasonable. Y min to y max, 0 to 50, going by 5s. I press graph and I see my graph. Now, part C of this problem says what maximum height does the frog reach? Well, since we've already calculated decimal 1531, if we hit our trace button and type in decimal 1531 for our time value, it will take us right to that point on the graph. And it looks like it's around 36.48. So back to our slides, 36.48 is the q value for the vertex. The maximum height, therefore, is approximately 36.48 centimeters, and it occurs at about the 0.1531 second mark. Next, when does the frog hit the surface of the water? That looks like it's the time when the height value is 0. Let's see how we can do that on a calculator, because we don't have the algebra skills yet to do it manually. So we could use trace and hope that we get somewhere close to the correct value. Takes a while of clicking there. You could do some guessing and checking. Just type in, say, 0.4 and see if that gets you there. That's pretty close. So what about 0.42? That's pretty close. Maybe 0.43 would be a better estimate. Another way, since we're looking for the height to be 0, we go to second calc and choose option 2, 0, left bound, just be a little to the left of the point of interest, right bound a little to the right of the point of interest. Press enter, and it looks like 0.4259. So the frog hits the water at about the 0.4259 second mark. What are the domain and range? Well, the domain is the allowable t values in this case. So I've written them down here. The permissible values of time are from 0 to 0.4259 approximately. That's the best we can do under the circumstances. And the range, the height values are from 0, a low of 0, to a high of about 36.48. For part F, we want the height at time 0.25 seconds, so we have to substitute 0.25 in for t. So we do that, perform the calculation, and we get 31.875. That's in centimeters, of course. Now, here are the parameters you should be familiar with for problem-solving situations. Interpret the meaning of the different parts of the graph and the function.